All right. We are in section 13.5 where we get to apply the law of sines. So up to this point, when we're dealing with sides and angles of triangles, we've been working with right triangles. And that's allowing us to apply the definitions of those trig functions with right triangles. Now we're going to go away from right triangles for a bit and being able to solve any kind of triangle. And being able to initially solve it is by using what is called the law of sines. The law of sines is if you have a triangle like we have represented here with angle A, B, and C are in capital letters, and you notice that the opposite side is its lowercase. So I have, my A here, and the opposite is small case a, B here, and then C here. Okay. So with that being said, we have to do a little bit of review of geometry. To be able to use the law of sines, you have to make sure that they're either in AAS form, ASA form, and or SSA form. So this one is angle side. This one is angle side angle. And the last one is side angle. And when you're looking at those, you can make the conclusion on whether you're going to find one triangle, two triangles, or no triangles from the given angles or distances that you're provided for each problem. So let's take a look at example A. So I want to be able to solve this triangle, and I want to use what I would use for the most part. I would draw out a triangle to kind of help you out. So I'm going to have like that, just an arbitrary triangle. Go A, B, and C. And so this is, they give us is 94. They give us this is 67. And then they tell us that B is 25. So it's the opposite distance of what that angle is. So first thing you can do is I can figure out what B is by taking 180 degrees, because the sum of all the interior triangles is 180 degrees, subtracted by 94, and then subtracted by 67, and I'm going to get a value of 19 degrees for B. Now, what we don't have is we don't have what small a and small c are, but we can use the law of sines to help us do that. So it's a proportion. So I can take the sine of 94, because that's my a, divided by small a, will equal sine of 19, which is b, over the value of b, which is 25. So if I were to cross multiply here, I would get the sine of 19 times it by a is going to equal something roughly, was it the sine 94 times by 25 is going to give me 24.94. And then if I were to divide that by the sine of 19, I would get something like, for the a distance of 76.6. And then to find c, doing the same thing, I can go the sine of 67 over small c equals the sine of 19 over 25. It's important to try to use the as many given values as you can in order to solve, because I could have used the sine of 94 over 76.6, but it's better to just use the values that are given to you to help you solve for the unknowns. So doing that, same thing, doing the proportions. Okay, so now I have, again, the sine of 19 multiplied by c equals sine of 67 times it by 25, which gives me 23.01. Sorry. Excuse me. Now if I divide it by the sine of 19, I get c equaling 70.68. So the unknowns that I had were 19 degrees, 76.6, and then 70.68. And it's the same thing for B, just do the proportion. One thing you have to keep in mind is when you're looking at these triangles is if you identify that it is a side angle, an SSA triangle, it can have one of three solutions. It can either have one triangle, two triangles, or no triangles. And what we're saying is that if it's no triangles, it means like it doesn't, one of your sides doesn't close in. And if you have two triangles, that means that the distance for A can either go to the left of H or to the right of H, depending on what the given values are for each particular triangle. So all I want to do to identify what examples A, B, and C I have is I just want to determine whether this has one triangle, two triangles, or no triangles. So the first thing I have to do is identify what A is. Is A acute or an obtuse angle? So for this one, it's 127. This one is an obtuse angle. So that means that I have two stipulations. So I have to identify if the distance of A is less than or equal to B, or if A is greater than B. So if I look here, I notice that A is greater than B. So if I go here, A is greater than B, so that means that this here is just one triangle. Okay? For example B, it gives you angle B in this case. So if you find yourself in a problem that it gives you a different letter. So let's just remove that and just make it A. But then I'd have to remove this one, and this would be distance A, and then this would be distance B. Just so you're trying to be as consistent as possible, and you're looking at the chart. So when I look at this, I notice that our new angle A now is 52 degrees. And 52 degrees is an acute angle, so that means we have 4 different scenarios that's going to help us. One of which is we have to find what H is. And to find H is you can take H equals B times the sine of A. So if I look at this one here, if I take H equals B times the sine of A, that means it's going to equal 6.5 times the sine of 52. So if I go sine 52 multiplied by 6.5, H in this case is going to be 5.12. So now we have all the stipulations to determine whether it's one triangle, two triangles, or no triangles. So I have, so right now I got what, 6.5 is B and 4.7 is A. And if I look up at the chart, Let's take a look at number 1. Is H greater than A? So I see that the first one is if H is greater than A, which in this case, this is true. And since that's true, that means that this one has no triangles. All right. Looking at example C, I have A being an acute angle, so that means I have to find what H is. So H here is going to be B times the sine of angle A, which means that I'm going to have 34 degrees times it by the sine of 62. So the sine of 62 multiplied by 34 equals, so H in this case is going to be 30.02. So now I know that H is 30.02. I can look back at my chart. Number 1, is H greater than A? No, it is not. Is H equal to A? No, it is not. Is H less than A, but is A less than B? Yes, it is. And since that is a true statement, I can say that this is going to make up 2 triangles. Okay? Last thing we're going to do is I'm going to show you how to find the area of a triangle using it's incorporating with the law of sines, because in this case we don't know what H is, but again, H is in that formula, because what was H over up there? It was B times the sine of A. Depending on what values you're given, that's how we're going to be able to find H using the area of a triangle, which was it's 1/2 B times H, which was the general formula that you've been learning either in geometry or in other algebra classes. So basically, for example A, you're given B and C and you have angle A, so that means that you're going to use this format to help you solve it. So I can say that A equals 1/2 B, which is 11, times it by C, which is 7, multiplied by the sine of 120. So if I take the sine of 120, multiply it by 7, multiply it by 11, times it by 1/2, I get an area of 33.34 square units. Same thing goes for example B. It looks like I'm going to be using this one to help us solve it. So I'm going to have A equals 1/2 A, which is 11, and then C, which is 18, times it by the sine of 85 degrees. So if I go sine of 85, multiply by 18, multiply by 11, times it by 0.5, or 1/2, this is going to give me 98.62 square units. And that is being able to apply the law of sines. Hope this helps. Until next time.